by Marina Koren, a collection of defunct spacecraft. Their mission to chronicle the wonders of the universe long ended, glide silently in Earth's vicinity. This week, NASA will turn off another, the Spitzer telescope, which has spent 16 years observing the cosmos. The telescope trails the Earth, looping around the Sun, and little by little, it has drifted away from us. The growing expanse, now hundreds of millions of miles wide, has made it trickier for engineers to operate Spitzer and point it at the right places: the Sun, to charge itself; Earth, to transmit data; and the dusky universe beyond, to collect even more. So they've decided to junk it. Objects in space, even very expensive, prized telescopes, are considered debris when they no longer have a purpose or function. Some, like Spitzer, were lofted into high altitudes or special orbits, and will stay out there for anywhere from hundreds to millions of years. Kepler, the NASA telescope that discovered thousands of planets before it ran out of fuel in 2018, coasts along behind Earth. Herschel and Planck, two observatories from the European Space Agency, ceased operations in 2013, but still hang a million miles away at a spot in space where a quirk of gravitational forces maintains objects in stable orbits, almost as if by magic. The Galaxy Evolution Explorer, a NASA telescope that did exactly as its name suggests until 2012, is expected to circle Earth for nearly 60 more years before burning up in the atmosphere. Copernicus, one of NASA's earliest observatories, is still up there after ending its X-ray observations in 1981, going round and round Earth. The list goes on. Together, these expired spacecraft add up to more than a pile of space junk. They are a floating record of years' worth of scientific inquiry, launched from the minds of explorers who couldn't fly there themselves. Each one tells a story about the state of knowledge at the time it was launched. Alice Gorman, an archaeologist who studies space exploration, told me. Spitzer, named for Lyman Spitzer, the American astrophysicist who called for space telescopes long before anyone had even launched a satellite, is designed to detect sources of light in infrared wavelengths. In the 1960s, scientists curious about seeing the cosmos in this way attached infrared telescopes to balloons and lofted them into the sky. They needed to get past Earth's atmosphere, which absorbs this kind of radiation. Trying to see faint infrared sources from the ground, NASA explains, is like trying to observe stars while the sun is up. A National Academy of Sciences report in 1979 encouraged the deployment of infrared telescopes, saying that in recent years, the sensitivity of instruments used for infrared astronomy has been improved by more than 2 orders of magnitude, leading to exciting findings about neighboring planets and distant stars. By the 1990s, NASA was working on Spitzer. Spitzer's sensitivity to infrared light allows it to see very faint cosmic objects. Its discoveries stretch from our own solar system to the edges of the universe. Spitzer found a ring around Saturn made of dust particles too spread out for other telescopes to see, and caught the light that left galaxies billions of years ago, not long after the Big Bang. By the end of its life, Spitzer was contributing to an area of study that barely existed when engineers were first laying out its blueprints: exoplanets. Spitzer detected chemical elements and even weather patterns in the atmospheres of distant planets orbiting other stars. Once decommissioned, space missions aren't expected to come back from the dead, but it has happened. Last year, a NASA spacecraft launched to study Earth's magnetosphere miraculously resurrected 13 years after it was presumed broken, but, sadly, it never returned to full operations. It's still orbiting Earth, though. Spitzer is expected to remain in orbit for many, many years along with its silent brethren. Spitzer and Earth will remain in a strange little dance as they move around the Sun. According to NASA, Earth will catch up to Spitzer in 2051, approaching from behind. The encounter will push Spitzer into an orbit closer to the Sun, where it will travel faster, leaving Earth to trail after it until their next close approach. The long afterlife of these spacecraft presents an intriguing question for Gorman. Years from now, there may be many more space archaeologists, and some of them might be curious about what their ancestors left behind in the space near and around Earth. If a future observer was trying to get an idea of the state of terrestrial science, could they infer it from the age of the spacecraft and the nature of the instruments on board? Gorman says, "It's certainly possible. In some cases, future researchers could tell what defunct spacecraft used to do just by looking at them. Different kinds of equipment are required to study different wavelengths, and space archaeologists could work out the meanings of the hardware from dusty documents on Earth and compare them to their views of the spacecraft. The hardware for gamma and X-ray detecting spacecraft, for example, is quite distinctive, according to Fiona Panther, an astronomer at the University of New South Wales at Canberra. Some spacecraft might hang on to traces of samples, says Michael Bush, an astronomer at the SETI Institute. Future archaeologists equipped with spaceship technology could sidle up to dead spacecraft and discover that their instruments were designed to collect grains of space dust. With enough observations and fieldwork, at historic sites that zoom through space at nearly 17,000 miles per hour, future generations of researchers could trace the technical development of space science in the 20th and 21st centuries. Studying the changes in space telescopes, the evolving technology, the new questions they were designed to answer, would be analogous to studying the progression from the Wright brothers' airplanes to commercial airliners, Gorman said. From this perspective, space observatories would someday make great museums, like Smithsonian's famous Air and Space Museum, only, in actual space. You can visit terrestrial, conventional museums and you can see old cars, planes, trains, boats. Stuart Eaves, an engineer and an advocate for the creation of space museums, once told me. It would be a real shame if some of the really iconic spacecraft that have contributed enormously didn't have some sort of permanent record. Space companies today are already experimenting with, and having some success, capturing dead spacecraft in orbit around Earth. They're doing it as part of an effort to clean up an environment filled with space junk, but similar technology could be used to pull historically significant spacecraft into higher, safer orbits, or even toward one another to create an exhibit. Imagine a little gold plaque orbiting beside Spitzer, explaining to spacefaring visitors how the telescope once showed us more of the universe than we could imagine.